Assalamualaikum. Okay, so since I'm on birthday off, okay, let's do example 12 via YouTube. Right, so this is on page 123 from your textbook. Right, okay, so let's read the question first. They say a ship A has position vector 3i plus 4j at 1300 hours, 1 o'clock, whereas I and J represent 1 kilometer east and north of a harbour respectively. Okay, so there's this particular harbour. Okay, and then after that, if you want to go east by 1 kilometer is I. Okay, and if you want to go north of that harbour, okay, by 1 kilometer, that is called J. Okay, 1J and 1I. Okay, so 2 hours later, that means now it's at like 3 p.m. Okay, 2 hours later, the position of A is now at 2I plus 8J. Okay, so the first question they want you to find is find the velocity of A. Right? Okay, so what you're going to do is, see, earlier on we have established that R is equals to R naught plus VT. Okay, so R naught is position vector of 1 point on the line, okay, whereas V is the velocity, okay, and T is time. Okay, so having known that the ship actually landed on 28 will be here. Okay, this is the position vector, the end result. Okay, and then it must be equal to a certain vector first, a certain vector on the line, and that vector should be the starting position, okay, of the ship, which is 3i plus 4j. Okay, so that will be 3, 4. Okay, and then you need to plus with the V and T, right? But V we don't know, that's the thing that we want to find. But T, the time, we should know because they say it's 2 hours, so we can take T to be the number of hours. So this one is actually 2. Okay, so rearrange everything, you should be able to get V to be negative 0.5 and 2. Okay, this unit is kilometers per hour. Okay, so that's how we arrive at the velocity using the velocity equation. Okay, next, find the speed of A. Okay, so as mentioned earlier, velocity is actually speed but with direction. Okay, whereas speed is just the magnitude part of it. Okay, so for you to find the speed, okay, it is actually the magnitude of V. Okay, so in the book they already calculated square root of this square plus this square. So negative 0.5 square plus 2 square. Okay, the answer is 2.06 kilometers per hour. Okay, so you notice that if you want the speed, you write it as a number, but if you want the velocity, you need to write it as x and y in a column vector form. Okay, if it's 3-dimensional, then x, y, and z in column vector form. Okay. Right, so we are done with the speed. Okay, so part C, write down the expression for the position vectors. For the position of A, t hours after 1300 hours as a single vector. Okay, so we know the equation of the line is actually supposed to be like that. R is equals to 3, 4, the position vector at the start. Okay, and then plus negative 0.5 and 2, okay, and then T. Okay, so take note, this is called R naught for a reason. Naught is actually 0, that means the initial position. Okay, so this is very good to know. Okay, alright, so what they want is, they want it as a single vector, so you cannot write it as 2 vectors like this. You need to write it as R is equals to 3 minus 0.5t, combine them together, and then 4 plus 2t, combine them together. Right, and you're done. Okay, that's the position vector of the ship. Okay, at the time t, okay, written as one vector. Okay, alright. The last question for this part is find the time at which A is directly north of the harbour. Okay, so we know that no matter where they are, it must follow this particular equation. Okay, so now let's try to make sense out of it. We want the ship to be directly north. Okay, so if it's directly north, let's draw a simplified diagram. It could be here, because north is the y-axis, right? Okay, the north is the y-axis, the x is the east, right? Okay. So that means the boat can either be here, or anywhere on top. Okay. Anywhere on the y-axis, okay, the x must always be 0. Okay, you know that you want to find x y-intercept, you always write down x equals to 0. Okay, so what you're going to do is you're going to use this equation. Okay, but you're going to force the x component to be 0. Okay, because then the boat will be directly north. Okay, if the x is not 0, let's say it's positive, it should be somewhere here, and if it's negative, it should be somewhere there. It's not directly north. Okay, so that's what the book did. They write x equals to 0. So let's try to solve this. Okay, so we have x equals to 0, meaning your this part 3 minus 0.5t must be 0. Solving this, you get t is equal to 6. Okay, that means after 6 hours, the boat is directly above the harbour. Okay, let's call this harbour H. Okay, alright. But the thing is, they want you to find the time. Okay, so okay, but the question didn't specify, but they also want the distance. Okay, right. So the distance is just a vertical distance here. Okay, so that means we want the y component of this. Okay, so at t equals to 6, you substitute it here. Okay, your r is equals to, we know it's 0, right? Okay, and then after that 4 plus 2 times 6. Okay, let me check. Okay, so it's 4 plus 12, so it is actually 0, 16. Okay, that means it is actually 16 kilometers north of the harbour. Okay, right. So we have done example 12. Okay, so you can go to the exercise 3O. Yeah, it's a 3O, and give a try for some of the questions. Okay, so I'll let you know what the questions are via Saida, inshallah. Okay, alright, so that's it for today. Hope you learned something. Okay, I'll see you when I come back to school. Okay, Assalamualaikum.